In this video, we're going to be practicing power rule. If you want to follow along, the companion worksheet can be found in the link below. So power rule is basically the very first rule in finding derivatives in calculus. So we're going to start with this first example of f of x equals x to the third power. And the rule is that when we have an exponent, what we do is, to find the derivative, we bring that number down in front as a coefficient. Now what happens is the power on our variable, in this case our variable is x, it changes. It decreases by 1. So this becomes x squared. Now the way we write a derivative is we write it f prime of x when we're using function notation. Now there's going to be another notation that we will also use later on. But when we have functions, we use f prime to denote that this is our derivative. So for our second example, we don't have function notation. What we have is y. So the notation that we use here is, well, y is our dependent variable and x is our independent variable. So we write dy over dx. Now we can't yet take the derivative here because this 1 over part of it often gets people into a lot of trouble. But what we can do is we can say, well, this is really x to the fourth raised to the negative first power. Now when we have two exponents, well, we can handle that with some algebra. We just multiply them. So here in this problem we have x to the negative fourth power. And now this looks much similar to what we had up top. So now we can find this derivative by bringing down the negative 4 out in front. And now this exponent is going to decrease by 1. Keep in mind though, this is already negative. So by decreasing it, it's going to be x to the negative fifth. Now oftentimes teachers will want you to write all your answers with integer, or in some cases, whole number exponents. So if you're asked to simplify past this point, we'll show you how to do that. The idea here is that raising something to the negative power, all that does is make it the reciprocal. So what I'm doing here is I'm just undoing what we did over here, where here we put these two together and multiplied them to get negative 4. Here I'm saying, well, negative 5 is what you get when you multiply 5 and negative 1. Well, what does it mean to raise something to the negative first power? That means that we take the reciprocal, 1 over x to the fifth. So that's what that does. And we can combine these two and write it as negative 4 over x to the fifth. So with example number 3, here we're using function notation again, but here we have a square root. So before we can take this derivative, we have to ask ourselves, well, we need an exponent. So what is square root as an exponent? Well, that's s to the 1/2 power. So to write our derivative, it's going to be f prime. Now s is our independent variable, but that's okay. Whether it's x, s, or something else, the power rule still holds. So the 1/2 comes down in front times s. Now the exponent's going to decrease by 1. So when we subtract 1 from 1/2, we get negative 1/2. Now what that means is now we have a negative exponent. So we have to resolve it like we did up here if your teacher wants an answer with whole number exponents. So that means we'll write this as 1/2 times s to the 1/2 raised to the negative first power. So we have 1/2 times 1 over s to the 1/2. Now if your teacher wants a whole number answer, that means we also have to deal with the fact that, well, this is not a whole number. But we already said that s to the 1/2 is the same as square root of s. So we'll write this as 1 over square root of s. And then when we multiply them together, we have 1 over 2 square root of s, which is equal to f prime of s. So for our next example, here we have g of x equals 4th root of x to the 3rd. All right, we've got x cubed inside, and we've got the 4th root outside, and that's the same as raising something to the 1/4 power. So when we put all that together, we have x to the 3/4. So now, to apply power rule, our answer is going to be g prime of x equals, we're going to bring down the 3/4, and we're going to subtract 1 from this exponent. And so when we take 3/4 minus 1, that's the same as 3/4 minus 4/4, we get negative 1/4. And that's what g prime of x equals. And again, we'll simplify this. We have 3/4 times x to the 1/4 to the negative 1 power. And that's the same as 3/4 times 1 over x to the 1/4. Now, x to the 1/4, well, we said that that was the same as the 4th root. So this simplifies to the 4th root of x. So when we combine these, we get 3 over 4 times the 4th root of x. That is our derivative. That is what g prime is equal to. Now looking at number 5, here we don't have x or y like we're used to. We have s and r. Now s is by itself, so that's an indicator to us that this is the dependent variable, while r is the independent variable. Now later on we'll get into implicit differentiation where those two we will mix them. But for now, when they're separated, it's a reasonable assumption that what's out here is dependent. So that means when we write our derivative, it's going to be ds over dr. Dependent on top, independent on bottom. But can't write this, can't find the derivative yet because, well, we have to write this as r to some exponent. So let's see what we've got. We've got several things. We've got r to the 4th power. Now on top of that, we have the cube root. Well, that's raising it to the 1/3. And then on top of that, we also have 1 over. That's a reciprocal. So that means it's also being raised to the negative 1. So here we have 3 exponents going on. Well, we can multiply 3 numbers at the same time. That's fine. When we do, we get r to the negative 4/3. So now that we've written it in the form that we want, now we can go ahead and say, all right, well, bring down the negative 4/3. Now the exponent's going to go down by 1. So when it goes down by 1, now it becomes negative 7/3. All right. Now let's break this apart into what it was before, similar to this. We have negative 4/3 as our constant. And so we have r to the 7/3. And outside we have a negative 1. Now what's the negative 1 going to do? Well, that's going to give us a reciprocal. So we have negative 4/3 times 1 over r to the 7/3. But let's break that up some more. Here we have negative 4/3 times 1 over. Now we're going to break this up into r to the 7th to the 1/3. That's how 7/3 breaks up. 7 times 1/3. Well, 1/3 is cube root. So this is going to be 1 over cube root of r to the 7th. So when we multiply that coefficient in, we have negative 4 over 3 times 3 cube root of r to the 7th. And that is our simplified derivative of ds dr. Now looking at example number 6, here we have f of a equals 1. Now it's saying that a is our variable, but it's not present. What does that mean? Well, that means that we have a raised to the 0 power, because anything raised to the 0 power is really just 1. And so thinking about this, we can write the derivative very easily, because what happens? Well, if we bring down the 0, it's going to be 0 times, well, I can stop here. It doesn't matter what I write after this, because 0 times anything is still 0. And so that is our derivative. So anytime you think of you see a constant, think of the variable being raised to the 0 power. And so for our last example, what we have is we have a generic form where we have f of x equals x to the nth power. So our derivative is going to be, well, we take the n, whatever it is, it's some number, write it out front. And what happens is this is going to go down by 1. It's going to decrease. So we're going to write it as x to the n minus 1. And if you look in any algebra calculus textbook, you will see that this is the definition of power rule. So, thanks for watching. If you liked the video, please give a thumbs up. If you want more videos, click that subscribe button. And if you want to support the channel, head over to our Patreon page. Thanks a lot. Hope this helps.